It's 11:40 at night and your phone is blowing up. Not with news, with photos. The sky over Toronto is green. Over Dallas, it's red. Your cousin in Mexico City just sent you a video of the Northern Lights. And she has never once seen the Northern Lights. Because she lives in Mexico City. You step outside. It's beautiful. The whole street is out there filming it. And somewhere in a control room a few hundred kilometers away, a grid operator is staring at a screen, watching numbers climb, and quietly starting to sweat. Because you're looking at the sky. He's looking at the transformers. Here's the thing, nobody filming that aurora understands. The light show is not the storm. The light show is the receipt. The storm itself is invisible. It arrived hours ago, and it isn't aimed at you. It's aimed at every machine that remembers who you are. A solar superstorm isn't one event. It's three, and they arrive at different speeds. Punch 1 is light. When the sun fires a major flare, the X-rays cross 150 million kilometers in 8 minutes and 20 seconds. You get no warning, because the warning travels at the same speed as the problem. This punch blacks out high-frequency radio on the entire daylit side of the planet. Airline pilots over the ocean lose their long-range comms first. Punch 2 is radiation. Charged particles accelerated to a fraction of light speed show up somewhere between 30 minutes and a few hours later. Satellites start taking hits. Astronauts get moved into shielded sections of their station. Flights near the poles get rerouted, which airlines hate, because a rerouted polar flight can burn tens of thousands of dollars in extra fuel. Punch 3 is the big one. The coronal mass ejection. 1 billion tons of magnetized plasma, physically thrown off the sun, crossing the gap in 1 to 3 days. The famous Carrington Event of 1859 made the trip in about 17.5 hours, which is roughly 4 times faster than normal. Punch 3 is the one that goes after the grid. So what does a cloud of plasma actually do to a planet? On its own, nothing. Earth's magnetic field takes the hit. But when that field gets violently shaken, it does something you learned in high school physics. A moving magnetic field creates current in any long conductor sitting inside it. And we have wrapped this planet in long conductors, high-voltage transmission lines, railway signals, pipelines, undersea cables. During a superstorm, every one of them becomes an antenna, and the current flowing into them is DC, which is a problem, because the grid's most expensive components were never designed to swallow DC. The machine that matters most here is the large power transformer. These are the size of a small house. Many weigh over 200 tons. Each one is custom-built for its location. A lot of them are decades old. And if one cooks itself, the replacement lead time is commonly 12 to 24 months. Not 12 to 24 days. Months. You cannot run to a store and buy one. There is no store. If this sounds theoretical, it isn't. It has a date. March 13th, 1989. A storm hits the Hydro-Québec grid. Geomagnetic currents trip the protection systems, and the entire province goes dark. 6 million people. And here's the number that should stay with you. From first alarm to total collapse took 92 seconds. 92 seconds. Operators didn't respond too slowly. There was no version of responding fast enough. October 2003, the Halloween storms, a blackout. In southern Sweden, transformer damage reported in South Africa, and satellite operators worldwide in crisis mode. February 2022, a storm so minor it barely registered publicly still heated Earth's upper atmosphere enough to drag 38 brand-new Starlink satellites out of orbit. SpaceX watched roughly $50 million of hardware burn up in a week. From a mild storm, the 1989 event was not a superstorm. It was maybe a tenth of Carrington. That's the uncomfortable part. Now for the part almost nobody talks about. And it's not the power lines. It's clocks. GPS satellites are not really a map service. They are the most precise public clock ever built, and modern civilization quietly runs on it. Cell towers use GPS timing to hand your call from one tower to the next. Financial exchanges use it to timestamp trades to the microsecond. Parts of the power grid use it to keep distant stations in sync. Your phone's blue dot is the toy version. The timing signal is the real product. During a severe storm, the ionosphere, the charged layer these signals pass through, turns to static. Accuracy degrades or drops out entirely. And when the clock signal gets shaky, systems that have nothing to do with space start failing in ways that look completely unrelated. A card payment that won't go through, a trading halt, towers that drop calls for no visible reason. Nobody's power is out yet, and things are already breaking. So run the first 24 hours. Hour 0, the flare. Radio blackouts on the day side, and a warning shot for anyone paying attention. Hour 1, the radiation storm. Polar flights reroute. Satellite operators start powering down what they can. Hour 15 to 20, if it's Carrington-class, the plasma cloud arrives. There's one piece of good luck here. A spacecraft called DSCO-VR sits at a point between Earth and the Sun, and when the cloud rolls over it, we learn the storm's true strength 15 to 40 minutes before impact. That's the whole warning. Call it the 40-minute window. Inside it, grid operators make brutal calls, cut power to some regions on purpose, or risk the transformers and lose them for 2 years. A controlled blackout, chosen deliberately, is the good outcome. Then the shaking starts. The currents flow, and the sky over your street turns green. Lloyd's of London studied a Carrington-class hit on North America and put the cost between $600 billion and $2.6 trillion, with the worst hit areas potentially waiting months for full power. Insurance underwriters do not write trillion-dollar numbers for fun, and the storm that finally does it won't be a surprise. The sun throws Carrington-class ejections regularly. In July 2012, one crossed Earth's orbit at a spot our planet had occupied 9 days earlier. We didn't dodge it. We just weren't standing there, so go back to that street. Everyone's phone pointed at a glowing sky. Not one of those people will be injured by this storm. No burns, no radiation sickness, nothing. Every human body on Earth passes through it untouched. The storm only touches the grid, the satellites, the clocks, the invisible machinery holding the modern world together. A solar superstorm never lays a hand on you. It goes after everything you can't live without. And the prettier the sky gets, the harder it's hitting. If you want to know what we'd actually do about it, that's the next video. Subscribe so you don't miss it.